Hi guys, this is Colby Rybicki, and today we're going to learn about fire hydrant production. A fire hydrant is an above-ground connection that provides access to a water supply. The water supply may be pressurized, as in the case of hydrants connected to water mains buried under the street, or they may be unpressurized, as in cases of hydrants connected to nearby ponds or cisterns. The hydrant barrel, or the outer body, is usually molded in cast iron, ductile iron, or bronze. The hydrant bonnet, the conical cap, is usually made from the same material as the barrel. The valve stems are usually made from silicon bronze. The hydrant outlets are molded in bronze. If the barrel is cast or ductile iron, the bronze outlets are threaded into the barrel. However, if the barrel is bronze, the outlets are cast as part of the barrel. The outlet caps may be bronze, cast iron, or plastic. Valve seats, seals, and gaskets are made from a variety of synthetic rubbers. And finally, fasteners may be zinc-plated, steel, or stainless steel. The basic design and construction of pressurized fire hydrants in the United States are defined by the American Water Works Association, which sets general standards for hydrant size, operating pressure, number of outlets, and other requirements. Fire hydrants are made through a process of metal casting. The outer surface of a mold is formed using a pattern. To make the hydrant pattern, the hydrant's outer shape is generated in 3 dimensions on a computer. This data is then fed into a stereolithography machine, which uses laser beams to harden liquid plastic into the shape of the hydrant. The inner surface of a mold is formed by a piece called the core. To make a hydrant core, the hydrant's inner shape is machined into 2 halves of a block of aluminum or cast iron to form a cavity. The 2 halves are clamped together, and the cavity is filled with a mixture of sand and plastic polymer. And then, when the block of aluminum or cast iron is heated gently, the polymer hardens the sand to form the core. The block is then opened, and the core is removed. The entire hydrant is fixed lengthwise in a lathe, and shallow concentric grooves are cut into the face of the lower flange. This allows the flange to seal against a gasket when the hydrant is mounted. The flange at the base of the hydrant is the point of connection for the hydrant to the rest of the barrel. The valve stems, valve stem inserts, and valve disc holders are machined and threaded separately. Rubber O-rings are installed on the main valve to prevent leaks when the hydrant is closed. The AWWA, as mentioned earlier, standards require that bronze hydrants be rated at 150 psi and ductile iron hydrants be rated at 250 psi. Each hydrant is filled with water and pressurized at twice the rated pressure to check for leaks. And finally, I'll leave you with different fire hydrant designs from around the world. Thank you.